Hey guys, it's Miss Johnson, and I'm here to bring you your notes on complex numbers. That's our next section in the quadratic unit. We are looking at product and quotient properties of square roots. Okay, so if we think about non-negative real numbers that are underneath a radical sign, like this, I have the square root of a times b. I can split that up into the two factors as the square root of a and the square root of b. So as an example, I could say that the square root of 9 is equal to the square root of 3 times the square root of 3. Or the square root of 16 is equal to the square root of 4 times the square root of 4, which is 2 times 2, which is 4. So I can break apart numbers into their individual factors. I can do the same thing with division. I'm looking at the square root of a over b. I can split that into the square root of a divided by the square root of b. So if I had something like the square root of 49 over 81, that's the same thing as the square root of 49 over the square root of 81, which is 7 over 9. So I can split those things apart. Now, the reason we have those properties in place is because of this. When we simplify square root expressions, we are not allowed to have any radicals in the denominator, no radicals in the denominator, and we cannot have any perfect square factors under the radical. So those are two things that we're really going to have to take care of when we're looking at numbers and simplifying square root expressions. So let's just talk about how to simplify some of these square root expressions. So one thing that's a really good thing for you guys to know, and you can actually find a Google image of this. That's all I did was find a Google image of this whole perfect square table. Know your perfect squares through at least 15, even up to 20 would be really good because you're going to be looking for these numbers that are down the middle right here. These perfect squares are numbers that you're going to want to know. Okay, we're going to use those a lot in this unit. So simplifying square roots, let's take a look at the square root of 50. So what I want to think about is what perfect square factors can I break 50 apart into? If I split 50 into 25 and 2, 25 is a perfect square. Okay, so that's the same thing as saying the square root of 25 times 2, which is the same thing as the square root of 25 times the square root of 2, and the square root of 25 is 5. Okay, so I have 5 times the square root of 2 as that simplified expression. Same thing with the square root of 45. I want to look for a perfect square that comes out of 45. A perfect square would be 9. So I can split that into the square root of 9 times 5. That's the same thing as the square root of 9 times the square root of 5. And the square root of 9 I know is 3. So I have 3 times the square root of 5 as that simplified expression. Now I have no perfect squares left because there's not a perfect square in 5 and there's not a perfect square in 2 over here in part A. So I have no perfect squares left underneath the radical. Let's take a look at part C. In part C, I have the square root of 128. Now, if you're not sure what to break this down into, let me show you another way that would help you. Sometimes it's not easy to pick out the perfect square. So if I just go ahead and break this apart, start by just dividing. Let's say I take 128 and divide it by 4. 128 divided by 4 is the same thing as 32. So I could change that into 32 times 4. Then I also know that 32 is the same thing as 8 times 4. This 4 is the same thing as 2 times 2. All I'm doing here really is finding the prime factorization. So if I take a look at 8, 8 breaks down into 4 and 2. This 4 is 2 and 2. I'll keep these coming down. And this 2 one more time is 2, 2, that's a 2, that's another 2, that's another 2, and that's another 2, and another 2. So look at the factors of 2 that you have underneath here. You have 1, 2, 3, 4, 5, 6, 7 of them. So write that underneath the radical. 2 times 2 times 2 times 2 times 2 times 2 times 2. I have 1, 2, 3, 4, 5, 6, 7. And another way to think of this is that perfect squares are things that were multiplied by themselves. So anytime you see a pair of things being multiplied, that's going to make 1, 2 outside of the radical. So these two 2's underneath the radical made one 2 outside. These two 2's underneath the radical made another 2 outside of the radical. These two underneath made another 2 outside. I'm left with this one. It has no other factor of 2 to go with it, so it has to stay underneath the radical. And then put back together what you have left. I have 2 times 2 times 2 on the outside, which is 8, and then I have the square root of 2 left over. Okay, so that's just another way to simplify these. If you're not good at picking out which one of the perfect squares come out of a number, especially when you get into bigger numbers like 128 or something, then you can look at it this way. You can look at it as pull it all the way down to the prime factorization, and anytime you see a pair, take that pair outside. That also helps us when we get into looking at variables. This is the same thing as the square root of x times x. X squared is the same as x times x. Well, I have a pair here. This pair of x's can come out front to make one x outside of the radical. Then I've gotten rid of everything underneath and I have no radical part left. The square root of x squared is x. Okay, let's take a look at a couple more together. If I look at part E, in part E, now I have a number part and a variable part. So the square root of 25, I could break that down into its prime factorization, which would be 5 times 5. I can break down the x squared, that would be x times x, and I can even break down the y's, that would be y times y times y times y. I didn't quite make my radical sign long enough. Now, anytime that I see a pair of something like this pair of 5's, it's going to come out to the front. This pair of x's comes out to the front. This pair of y's comes out to the front. This pair of y's comes out to the front. So I took care of the 5's, the x's, this pair of y's, that pair of y's. There was nothing left over underneath. Now I just need to multiply what I have left on the outside. That's going to be 5xy squared. If I look at it with a fraction, now I'm looking at x squared over x. And actually, you know what? We're going to stop our video there for today, and we'll come back to the fractions tomorrow. So go back to Schoology and take your quiz for our notes through this point, and we will come back together tomorrow and look at the rest of them. Thanks for watching, and have a good night.